Let's have another example of network analysis. Water is flowing through a network of pipes in thousands of cubic meters per hour as shown in the figure below. So, we are asked to solve the system for water flow x sub I is equal to 1 to 7. We have to know how much water flow we'll have in the pipes where the edges are the pipes. Find the water flow if at x sub 6 and x sub 7 the water flow is 0, and the water flow if at x sub 5 it's 1000 and x sub 6 it's 0. So pause the video and try to answer this problem. Alright, so we will assign numbers in our vertices so that we'll be able to create a system properly. So let me use a different color. I hope this will be seen. That's one. Oops, not seen. Wait a moment. Let's make this as 1, 2, 3, 4, 5, and 6. So at vertex 1, we can see 600 going in and x1 and x3 going out. So therefore, I can write it as 600 is equal to x sub 1 plus x sub 3. But to make it a bit more conventional, we'll have x sub 1 plus x sub 3 equals 600 because we're used to the variables on the left side. For equation 2, we have x1 coming in, then x sub 2 and x sub 4 going out. So I'll have x sub 1 is equal to x sub 2 plus x sub 4. Now, so I'll be able to have also an equation that is conventional. I will transpose both x sub 2 and x sub 4 to the left side. So I'm going to have x sub 1 minus x sub 2 minus x sub 4 equals 0. For the third vertex, we have x sub 2 coming in and x sub 5 coming in, but what comes out is 500 cubic meters per hour. So therefore, I'm going to have this as x sub 2 plus x sub 5 equals 500. And that can already be my equation here because it looks conventional already. Now, at vertex 4, we have x sub 3 and x sub 6 coming in, and 600 comes out. So I'm going to write it here already. X sub 3 plus x sub 6 equals 600. Then let's just fix that. There you go. We can now have for vertex 5, we can now have x sub 4 plus x sub 7 coming in, and what comes out will be x sub 6. So transposing that, we'll have x sub 4 minus x sub 6 plus x sub 7 equals 0. Finally, at vertex 6, 500 comes in and it's separated to x sub 5 and x sub 7. So therefore, I'm going to have 500 is equal to x sub 5 plus x sub 7. To write it conventionally, x sub 5 plus x sub 7 equals 500. So now we have 1, 2, 3, 4, 5, 6 equations, and we have 7 variables. So let's now write our matrix, which will be kinda long. 6 equations, 7 variables. So I'm going to write it here. 1, 2, 3, 4, 5, 6. There you go. Quite a long matrix. So for the first one, since we have x sub 1 plus x sub 3 equals 600, and we know we have other variables, it will become as follows. 1, 0, 1. Then 4 zeros here, then 600. For the second, we'll have x sub 1, 1, x sub 2, negative 1, x sub 3, 0, x sub 4, negative 1, x sub 5, x sub 6, x sub 7, then the constant of 0. Here, as we can see, we have to be extra careful because the augmented matrix is based on the system that you have constructed. So let's write out the other rows. So we have already written our matrix to save time. And just to double check, for example, we have x sub 3 in the 1, 2, 3, 4th equation. So 1, 2, 3, 4, x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, x sub 6 equals 600. So there. And now, we now have our matrix to solve. So we can use Gaussian or Gauss-Jordan elimination rather, and like what we've been doing, it is not the focus here. So I will leave it to the viewers what would be the actual process of the elimination. So now I'll be showing already the reduced row echelon form of our matrix. And the reduced row echelon form would be as follows. Row 1 will be at 1, 0, 0, 0, 0, negative 1, 0, 0. Row 2 will be at 0, 1, 0, 0, 0, 0, negative 1, 0. And we'll just fill the rest out. So there we go. To save time, we have already rewritten the reduced row echelon form of our matrix. Now, based on the reduced row echelon form, we have here a row of zeros at the bottom. So I guess we have infinitely many solutions on this system. So let's take note of the equations. From the first row, we're going to have x sub 1 minus x sub 6 equals 0. And this will entail us that by transposing, x sub 1 is equal to x sub 6. Then from the second row, we had x sub 2 minus x sub 7 equals 0, which should tell us that x sub 2 is equal to x sub 7. Then we have x sub 3 plus x sub 6 equals 600. That's based from the third equation. From the fourth equation, you have x sub 4 minus x sub 6 minus x sub 7 equals 0, which can lead us that x sub 4 is equal to x sub 6 plus x sub 7. Then lastly, x sub 5 plus x sub 7 equals 500. So as we can see, I made it that the x sub 6 and the x sub 7 will be our parameters. Therefore, we can have the solution as follows. We can let x sub 6 be equal to t, where t is an element of the set of real numbers. X sub 7 will be equal to u. U is an element of the set of real numbers as well. Then we can also have x sub 1, which will be equal to x sub 6 actually, which is equal to t. X sub 2 is equal to x sub 7, which is equal to u. And then, let's scroll that up. Because of this one here, we can let x sub 3 be equal to 600 minus t. Because of this, x sub 4 would be equal to t plus u. And because of this, x sub 5 would be equal to 500 minus u.